All right, so in this video, we will explore and define what makes ratios proportional. We're going to look at three things. One, babysitting, a real life scenario. Second, buying cheese, if you're interested in going to the store and buying cheese and they sell it by the ounce. And lastly, what makes a ratio proportional? There are four properties that we're going to be looking at in particular. So here we are babysitting. It said you have been hired by your neighbors to babysit their children on a Friday night. You are paid $8 per hour. Put a box around that key information because it identifies the unit rate. I'm just going to hide that for 2 seconds. We know that's our unit rate. And then we are going to now complete our table. So at 0 hours, you will not get paid with this job. Right? So at 0 hours, you get no money. At 1 hour, well, you get your $8. 2, if I use that unit rate of 8 per hour, well, I multiply this times 2. I have to do the same with my 8. I multiply 1 times 3. I'm going to do the same with my 8, 24. And as you notice here, I can either add 8 or I can multiply it by that number. So I get 32. And 8 times 4.5 is 36. So the first question read, how can you find your pay for any number of hours using your unit rate? Well, that's exactly what we just did. We started with 1 for every 1 hour, you get paid $8. And I said, well, what if I work 10 hours? If I multiply 1 times 10, I'm going to do the same with the 8. So 8 times 10 would give me $80. So if you work 10 hours, you get paid $80. Each time I go back to my unit rate. How much would you get if you didn't get paid? Well, you're not going to get paid, so because you don't work. So how much would you get paid if you didn't work, rather? How much would you get paid if you didn't get paid? You would get paid $0 for 0 hours work. Notice this is also known as the origin, which we're going to talk about when we graph relationships. And last but not least, we have what blank to your pay if you triple your hours worked. That doesn't make much sense. So what would happen to your pay? I'm just going to paraphrase this. What happened to your pay if you triple the hours you work? Well, if you tripled the hours you work, you would triple the amount of money you make. You would triple your pay. So as your pay increases by 2, your wages will increase by 2, or the amount of money you make increases by 2. Okay. The same if you went from 1 to 4, it would have 8 times 4 would be the amount of money you would get paid. All right, so now we're going to actually graph this relationship or sketch the graph. So I know that the origin is so important to me, so I'm going to put 0 here. And I want to go back to see what are the two things we are comparing here? What are the two quantities or things that are being compared or worked with? I have hours worked. And I'm going to label that as my x-axis. I'm going to explain why. And I have my pay, which is my y-axis. So I'm going to go back here. And I'll put hours and pay. And let's talk about why is that the case. It's my x, my horizontal, and my vertical axis is my y. So in class, we define the x-axis sort of as that bossy friend, the one that sort of tells the y-axis what to do. In this situation, the number of hours I work determine how much I get paid. If I don't work, I don't get paid. If I work 1 hour, I get paid $8. If I work 2, I get paid $16. The x-axis is what is sort of the controlling factor. Right? So therefore, it's independent of whatever the y does. The y, however, is dependent on what the x tells it to do. So we're going to later on go further into independent and dependent variables. But when you think about what you're going to label your x and y axes, think, okay, which one is the one who's sort of controlling this scenario? And sometimes it's difficult to determine, to be quite honest. In this case, it's sort of like, okay, yeah, that makes sense. Hours worked do have are the ones determining how much you get paid. So I'm going to now label it. So I have 0. I'm going to I like to skip a line if I have some space. 1, 2, 3, 4. Looks like a 5, 6. And I probably won't even use all that. And I'm going to count by 8. So I could count by 4s. I can count by 2s, but I'm counting by 8s. So again, I'm going to skip a line. I'm going to do 8, 16. And it's sort of, I know, oops, what happened there? It sometimes helps to sort of know what you're working with before you do your scale, because if you're counting by 2s and all of a sudden you got to go all the way up to 100 and you have this number of space, you might want to choose different numbers. So 16, what was this? 8 times 2, 8 times 3, 8 times, looks like it's about to storm. All right, and I think that's as far as I'm going to go, just because. So at 1 hour worked, well, actually more importantly, at 0 hours worked, you get 0 money. At 1 hour, you get $8. 2, I'm going to go up to 16. 3, 24. 4, 32. 5 would be 40, right? So and later on, next year, you're going to just talk about discrete and continuous functions. But this is when you're measuring time. Time is a continuum, right? You can break time up into little minuscule seconds. So I'm going to actually connect these dots to say, you know what? All these little points in between these two bigger points still matter. That could still actually be divided into, I can still get paid by, let's say, the second. Now, is that always true? Maybe not in this case, but I want us to draw the line because it helps us in really visualizing this. So what type of relationship does this graph show? That's where we have to go to the 4 points of proportional relationships. And I'm going to skip over the buying cheese. We might not have time to do that. 1, this graph shows that as one quantity is a multiple of the other. Yeah, I think that sort of shows that. And if I go back to my picture, I have 1 to 8. 8 is a multiple of 1, right? 2 is a multiple of 16. In fact, it's still by that same unit rate, which we keep seeing, right? Per 8. Okay. Let's go to the next one. And I'll just show all of them. If the first quantity is 0, then the second quantity is 0. I can definitely see that in this graph, right? It starts at the origin. If you don't get paid, or you don't work, rather, you don't get paid. As one triples, the other does as well. Yeah, we could see that. I went from 1 to 8, so the next one is 2 to 16. They both tripled. Or doubled, rather. And then the graph of the relationship is a straight line through the origin. And again, now that we got that, it definitely, despite my penmanship, forms a straight line that goes or starts through the origin. Okay? So how would I define or describe this relationship? Well, it's a proportional relationship for those reasons that we just discussed. It forms a straight line that goes to the origin. Right? That starts at 0, 0. One quantity is a multiple of the other quantity. The next one is the buying cheese, and while I ran out of time to really go further in depth in this, we will have an opportunity to do this with the Nearpod. So hopefully when we get on Nearpod, you'll be able to, or have already, in fact, had a chance to sort of play around with this and see what this relationship tells you. And then lastly, you will also be asked to make a graph of that same relationship. But this is sort of the nuts and bolts. So in your notebook, you're going to make sure that you include all 4 of these properties, because they really help. We're going to come back to this time and time again to determine what is proportional and what is not proportional. Okay? Talk to you later.